Hi, Skyline. So, unfortunately, my wife is doing her own schoolwork today, so she's not able to help me film. But I've got a pretty cool lesson for you today. We're still talking about mechanical advantage, and I had a lot of fun making those little catapults last time, so I decided to make a bigger catapult. So we're going to have some fun with that today. What I did was took two 2x4s and cut it down into this. So this is the catapult. This is the arm that actually shoots stuff. This is what basically the same as the spoon we used. And to create the energy for it, we have this right here, which is just an old bike tube that's put between these two posts, and then I twist it until there's a lot of force coming out here. And basically, you put something in here. Where's it? There it is. Put it in here. It flies up, hits this. This stops short, and whatever's in this little dish here goes flying forwards. So this guy is about 2.5 feet tall, 3 feet long. It's pretty powerful, and I want to explain a little more in depth of how it gets its power. So this right here is, as I said, an old bike inner tube. And I've got it stretched in between these two pieces of wood. Now what we're going to do is we're going to twist this. And this is basically a big rubber band. We're going to twist that, and the more we twist it, the more force this is going to have to propel the throwing arm. So let's take a look and see what that looks like. So now we've got it up on its side. What we're going to do is, I have this little white piece here, which is just so I can easily fit the throwing arm into it without needing to do anything weird. And all I'm going to do is I'm going to twist this. So now I'm going to start twisting this. And you can see that as I start twisting this, these rubber bands are going to get more and more tight and have more and more spring to them. So let's put about 5 twists in it. I've got 1 so far, so 2, 3, 4, 5. So now this is really hard to hold. So we're going to need to get the other piece in here pretty quick. Alright, so I've got 5 twists in it. Now I'm going to put the arm in. There. And now this is nice and tight, and it's going to be able to propel this arm pretty quick. Alright, I got this thing all loaded up. Let's take a few shots and see how good it goes. Let's give this a go. So that wasn't too bad. I went 10-15 feet. So let's shoot it a few more times and see how far we can get it. It's kind of hard to see the rocks on the camera. I'll look over and show them in a minute. Some rocks definitely work better than others. Alright, let's go measure those out and see how far they went. So, the furthest rock went about a little over 13 feet. So, 13 feet, 7 inches. And that's cool, but it's not nearly far enough. I want to make it go further. So now I'm back in my backyard, and got the scale here. Let's see how much weight this throwing arm is actually pulling. There we go. We got it going. Alright. Got a reading of 0.74 pounds, so less than 1 pound. Not very much. So let's try a few different things to make this more powerful. The first thing we can do is put a few more twists in our rubber down here. We've got 5 twists in it right now, so let's take the throwing arm out and put in maybe another 3 twists and see if that raises the 0.74 pounds to anything more than that. Pop this out. So, 1, 2, 3. This is very hard to hold. Really doesn't want to twist that much. Alright, let's give it a shot now. We're going to give this one more go with the 8 twists and see how much weight we've got. And looks like we now have 2.1. So that's definitely a lot more than it was before. Alright, test 2 with 2.1 pounds of force. Oh yeah, it's flying way further. Let's throw a few and measure the farthest. Looks like it's going at least another 5 to 10 feet further. Two more. And last one, this one's nice and small. Alright, let's measure those. That was way further. My tape measure only goes to 15 feet, but I put a marker at the 15-foot mark. So we're going 15 feet plus 8 feet. So right about 23 feet. It's a huge improvement, but I still want to go further. We went to 8 twists. Let's try to go to 10 and see if that gives us more power. So much harder. 1. Possible it might just break this band. 2. Alright, 10 twists. Measure this. 2 more twists only made it go from 2.01 to 2.17, so it's not too much of a difference. So I think we're going to need to come up with a better solution to get more power out of this thing. What I came up with was we're going to add an additional piece of tubing from here. We're going to stretch this forward and put it over our little basket there. That is definitely adding a lot more force onto our arm. So let's measure it and take a look. This thing is real tight and the arm is much harder to push down. Hits a lot harder too. That more than doubled our pull weight. Now what's interesting is when we're looking at this arm, when we're measuring it up here, we're getting anywhere from 4 to 5 pounds, which is a ton. But when we get all the way down to here, down to the bottom, then we're only getting about 2.5 pounds. So it's still more, but less down here and a lot more up top. So we're gonna explore that and see if we can make that better, but let's test it and see how it goes. Now let's try it with our 5 pounds of force on there. I already tell it's a lot harder to pull down. It's gotta be a good 10 or 15 feet further than our last one. That's our furthest one. Let's go measure these out. I had to measure 3 different times because my tape ship measure is not long enough, but we did 15, another 15, another 15, and now we're here at 6 feet 5 inches. So we got 51 feet 5 inches. That's so much better, but I still think we can go further. This is the part where you guys come in. I want your opinions. What should I do next? I think we can hit 55, 60 feet easy. So what can we do? I've got more of this tube there. I've got elastics. What could I do to make this go further? So remember what I was saying? We're getting the most force up top here, but then as soon as we get down, it starts to go away. Now it happens because this, the throwing arm, is on the same plane. It's getting pulled the same way as that elastic. Whereas the one you see it's up here, it's making this nice L shape, which is going to give it more force. That's why it's more up top and less down here. So, should I make this thing bigger? Should I add more turns to this? Should I add maybe elastic from here going to the end so it's pulling it all the way up? Let me know in the comments what you think. I hope you guys enjoyed the video. As I said, comments are going to be enabled, so please leave a comment down below with what you think I should do next. Also, just for fun, what do you think I should shoot out of it next? I was thinking it might be kind of fun to shoot like an egg out of it and see how big the egg explodes. So let me know, comment down below, and